How long would it take us to go to Jupiter? The largest planet in our solar system is Jupiter, and there doesn't seem to be much discussion of the gas behemoth. So we determined how long it would take us to travel to Jupiter and decided to take matters into our own hands. The answer to that question is dependent on a lot of variables, including the path, speed, and person traveling to Jupiter. So let's go through each of these in this video in great depth to determine how long it will take to travel to the largest planet in our solar system. One of the most significant planets in our solar system is Jupiter. Jupiter is a fascinating planet with enormous anticyclonic storms and a magnetosphere that defies description. Saturn's stunning rings are the reason why so many people prefer visiting Saturn, but Jupiter won't let you down either. Jupiter has several attractions, such as its cold moons, which we shall talk about later in the film. A cost-benefit analysis would indicate that Jupiter is a better alternative if you needed to leave Earth for some reason. Thus, why would we wish to visit Jupiter? Jupiter's moons would be among the most compelling reasons to travel there. Despite being a gas giant, Jupiter possesses 92 rocky moons. It's like a miniature solar system all on its own. The best site to hunt for life in our solar system can be on Jupiter's moons like Europa, Ganymede, and Callisto, since they may have enormous liquid water reservoirs hidden beneath their frozen surfaces. How far would we have to go if we decided to visit Jupiter? There will be a long journey to Jupiter. Jupiter and Earth are like sprinters competing in a hot sun on a clay track. The gap between them is always changing since they orbit the sun at various rates. At their closest and farthest points, respectively, they are separated by roughly 365 million miles and 600 million miles, respectively. 600 miles is more than 24,000 times the circumference of the globe, just to give you an idea. And to give you a sense of how far Jupiter is, if we tried to go there at the pace that our cars normally travel, which is 70 miles per hour, it would take us around 800 years. On average, there are 483 million miles between the two heavenly bodies. Scientists must compare the advantages of burning more fuel against the considerable expense and length of time needed to achieve the goal while keeping these factors in mind. In addition to technological advancements in propulsion systems, the alignment of all the planets affects how long it takes to travel to a distant planet. What about spacecraft that have already visited Jupiter, considering that we are discussing traveling to Jupiter? There have been spacecraft that have visited Jupiter in the past. For NASA spacecraft, Pioneer 10 and 11, Voyager 1 and 2 were launched in the 1970s. They all four traveled straight to the gas giant. All of these people visited Jupiter, but none of them stayed. They accelerated toward the outer solar system with the help of Jupiter's gravity. But only two spacecraft, Juno and Galileo, have really remained in orbit in the past. Both expeditions took a more circuitous path to Jupiter, speeding through the asteroid belt and into Jupiter's orbit thanks to the gravitational pull of the inner planets. Less fuel is needed to travel the lengthy route, which is necessary to slow down enough to create a stable orbit. How lengthy were these journeys, then? The first spacecraft to reach Jupiter was NASA's Pioneer 10. It took the quickest route, which was just 640 days long, just under 2 years. In spite of this, it only just missed Jupiter by 130,000 kilometers. A spaceship follows speedier trajectories when its only goal is to view the planet cursorily. Before moving on to the outer solar system, the Pioneer 10 probe captured a few pictures of Jupiter. Similar to Pioneer 10, Voyagers 1 and 2 took about 600 days to complete their journey, but they were also able to go far closer to Jupiter than Pioneer 10 did, coming within 22,000 kilometers of the gas giant. The first space mission to spend several years orbiting the planet was NASA's Galileo Mission, which had the specific objective of studying Jupiter and its moons. In order to approach Jupiter's orbit and carry out its investigation, a spacecraft must move slowly and take a more circuitous path in order to stay close to the planet. A spacecraft traveling at a too fast speed would simply fly by the planet without entering its orbit. Although it took the Galileo Mission 2,242 days, or over 6 years, to get at Jupiter, it did so at the ideal speed. A Vega, Venus-Earth gravity assist, trajectory was employed by Galileo, the first spacecraft to spend several years in Jupiter's orbit. The spacecraft made one close encounter with Venus, 2 orbits about Earth, and then was launched like a disk in the direction of the innermost planet of our solar system. The New Horizons probe reached Jupiter in only about 405 days, traveling at a speed of around 45,000 miles per hour. This was the fastest time for any spacecraft to approach Jupiter. This space probe made an uncommon flyby of Pluto and several dwarf planets. It increased its speed and adjusted its trajectory toward the dwarf planet Pluto by taking advantage of Jupiter's strong gravitational pull. The probe's velocity was increased by about 8,700 miles per hour thanks to the gravity support from Jupiter. This assisted in cutting the length of its journey to the adored dwarf planet in our solar system by 3 years. There may be many other considerations if we discuss taking people to Jupiter, and the journeys themselves would likely take longer than the spacecraft. The Moon is where humanity have traveled the furthest in space. Due to the Artemis missions, we haven't been back to the Moon for the past 50 years and are now doing so. NASA estimates that it would take 9 months to travel one way and 21 months to travel round trip on the quickest, most fuel-efficient route to Mars. A comparable one-way journey to Jupiter would take roughly 6 years if we generalize the techniques used to compute this itinerary. A 4-person journey to Jupiter would require 48,000 pounds of food just to get there, and much more to return, according to NASA's prediction that a 4-person crew would need 8,000 pounds of food annually. All of the research and life support tools would also need to be launched into orbit from Earth. Also, we must safely arrive at Jupiter. Many difficulties would beset astronauts. Radiation is one of the biggest ones. Space travelers will need to protect themselves against galactic cosmic rays, which can lead to cancer and genetic damage, in addition to the constant radiation from the sun, which is not shielded by our magnetosphere. When spending a lot of time in space, astronauts will also experience a variety of psychological problems. Anxiety brought on by extended space travel may make crew interactions more difficult. These symptoms are made worse by conventional work schedules, isolation from family and friends. Even though astronauts receive this training, it takes place on Earth. Your viewpoint will alter after you leave our home world and witness the blue marble floating in space. These difficulties will be perfected and enhanced in the following years thanks to NASA's new generation suits and the upcoming Artemis missions. There is a route that scientists must consider before traveling to Jupiter. The Pioneer and Voyager spacecraft both took a straight course, but a spacecraft can also take a longer, more circuitous route, like Galileo or Juno. They would have to travel farther, passing rather close to a planet's orbit. This is why it is so crucial that they are in sync with one another. A spacecraft approaching the planet is drawn in by its gravitational force, which then slingshots it around and out of the planet. To accomplish this, the spaceship must rely on the planet's orbital energy. Even though the planet loses a minor amount of energy, the energy loss is so small that it barely slows down the planet's velocity. Finally, there is the issue of which approach to Jupiter is most effective. There is a more fuel-efficient way to go to Jupiter that will save you a lot of money and other precious resources, even though it may take you less time and less fuel to do so. High-speed satellites have a hard time slowing down to the right velocity and settling into a celestial body's orbit. Yet, spacecraft are designed to pass by planets with the aim of just glancing at the planet and snapping a few pictures before flying off to explore the uncharted territory ahead, much like any usual excursion through a dimly lit planetarium giving you a tour of the solar system. A flyover is what this is called. One of our solar system's most interesting and dynamic planets is Jupiter. The leading candidates for life outside of Earth in our solar system are Jupiter's moons, which contain vast seas hidden by thick ice shells and may just provide the ideal habitat for life to evolve. Thankfully, we have two significant space missions set to travel to Jupiter's moons. First up is NASA's Europa Clipper, a mission designed specifically to study Europa. It will launch in 2024, and by 2031, it should have entered Jupiter's orbit. As already stated, the spacecraft must take a long, meandering trajectory with lower velocity in order to stay within Jupiter's orbit as opposed to simply zipping past it. The European Space Agency intends to launch the Jupiter Icy Moons Explorer mission in 2025, and it will orbit Jupiter by 2029. In summary, a spacecraft as quick as New Horizons can get to Jupiter in just over a year, but if the mission's main objective is to pass by Jupiter, it will typically take 550 to 650 days. A spacecraft must be slow enough to approach Jupiter's orbit at precisely the right speed, allowing it to be caught by the gas giant, in order to study the planet and its moons. The gas giant has many things to offer to us and will help us learn more about our solar system. So, will we be able to shorten the journey to Jupiter? When will humans even attempt a mission like that? Share the video with your friends and let us know what you think in the comments below.